When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had.
Media Ops presents DevOps Connect, May 19th at RSA Conference. Christopher Krebs, former director of the U.S. Cybersecurity and Infrastructure Security Agency, will keynote in a live fireside chat with host Alan Schimmel, which will also include Q&A with the audience. Besides an exciting keynote, you can also attend 30 other sessions featuring a powerhouse lineup of DevSecOps experts. Sign up for this free event now.
Welcome back, everyone, to Paul's Security Weekly. Security Weekly listeners save $100 on their RSA Conference 2021 All Access Pass. RSA Conference will be a fully virtual experience from May 17th through the 20th. Security Weekly will be live streaming Monday through Thursday in the virtual broadcast alley, interviewing some of the top sponsors and speakers for the event. To register using our discount code, please visit securityweekly.com/RSAC 2021 and use the code 5U1Cyber. We hope to virtually see you there. JobFire has joined us. Joff, welcome. Joff is on mute.
Yeah, there we go. Let's
hey!
try. It's great to be here.
It's awesome.
Good to see everybody tonight.
Nice to have you. And for this segment, we're going to be talking about AMASS, a tool for attack surface monitoring. It's interesting, you can, I think a lot of the bug bounty kind of crowd is big on AMASS in this tool. I did interview Jeff Foley, the creator and maintainer, the lead maintainer, I should say. There's lots of contributors to the AMASS project on Enterprise Security Weekly. And it is kind of a dual use kind of thing. I think most people use it on more of a pen testing red team kind of style, but you can certainly use it to, what I want to encourage more of is scanning your own environments and understanding your own attack surface. I think to get a better penetration test and keep tabs on things yourself so you can constantly respond to them. So AMASS, that's what it's used for, basically to discover the DNS infrastructure in your environment, primarily discover your subdomains. And I think, if you configure it properly, you'll I think most people will find stuff you didn't know about. Like, I think almost 100% of the time, I've run it against stuff that I thought I knew about. I was like, wait a minute. I didn't know that was still hanging out there. Usually it's like stuff you're like, wait, I thought I took that down, but I really didn't kind of stuff. And those are those dusty corners that we talk about that can really hurt you when you face attackers and or pen testers. So AMASS is fully open source. It's written in Go. Again, there's lots of contributors to the project. Jeff did request that if you want to help out with the project, he's like, I kind of got like a lot of developers working on it because it's so popular, which is great. Awesome response from the community. He's like, I really need people to help write documentation. I'm like, you mean test? He's like, no. He's like, so many people test it all the time because most of the bug bounty hunters are running it all the time and giving him feedback. He's like, I really need people to help, update documentation and things like that. So diving into it, AMASS is really super easy to install. And it's interesting, along those lines, Adrian Sanabria had sent me a video from Linus Torvalds speaking at a conference, talking about one of the things he was talking about was Linux on the desktop and specifically applications. And in Linus's opinion, and he's like the most curmudgeon-y person like on the planet, but in his opinion, there's so many different ways to package an application for Linux, and that varies across all of the distributions, that it makes it super difficult for application developers to do that. Snap is one of those ways where it packages software in a neat package and also gives you some kind of like containerization and controls over what this running application, if you're using Snap, can actually access, which is interesting. And I think it's still kind of young. I think it definitely has potential to be the kind of standard Linux package manager, but anytime you use the word standard, especially in the context of Linux, the lines kind of blur and it's kind of a gray area. So I found that Snap it's getting there, right? But so to install AMASS, I mean, you could build it from source. And to be quite frank, like, I haven't seen a reason to really build it from source to have to go to that level. You certainly could. I didn't for this exercise. You can also run it in a Docker container, which is another great way to run it. But I found, this is Ubuntu 2004, snap install AMASS. It's as simple as that. It installs the latest version, and I checked to make sure that it was installing the latest stable version of AMASS, and that is in fact 3.12.3 as of this technical segment. Installs the latest version, and it's just there. And I'm like, you know what? Sometimes the less time you got to spend messing with stuff to install it and configure it and get it running on your system, the better, because it allows you to dig deeper into the application. And that's exactly what I've done in the configuration. And I'm sure many of you are already customizing the configuration file for AMASS. You can do all of this on the command line through command line switches. I don't know about you guys, but like, I found the configuration file for AMASS to be way easier. You got to spend some time reading the documentation and understanding like what all of the configuration file elements do and what it allows you to control. Once you do that, though, I found, like, before I was in the config file, like, my commands were like spanning multiple lines, and I found it easier just to go to the configuration file and swap those out based on what you're testing. If you got a config that works, because as you'll see, you're going to have to configure a lot of the kind of third-party providers, which is highly recommended for AMASS. Things like VirusTotal, which you have to go get keys for, and Shodan, and make sure you configure all those, and I'll show you some examples of that as well. So digging into the configuration file, you can run this in two modes, both active and passive. I kind of found that, let me see here. Can I scroll? It's giving me crap. It should be the, looks like it's like skipping, hold on, some of my configuration. Hang on. There we go. All right. So you get to see my lovely browser windows when I do that. So in the configuration, there's both passive and active as well. Passive just really doesn't make sense to me. Like, I kind of like being able to pull the TLS certificates and attempting to do zone transfers. I think that's totally fine, especially I'm scanning domains that I own and or have permission to scan. So I always put it in active mode. I haven't found too much of like a performance hit in doing that. I find I just get better results when I run it in active mode. So I always configure it to mode equals active in the configuration file. I then give my output directory, and I give it kind of a standard directory for all of my output. That configuration has to be there. Otherwise, you have to specify it on the command line. So the ones that I highlight in bold, and you can grab this PDF file from our show notes page on our website, and you can get all these commands in the configuration file. So this PDF is available that I'm displaying on the screen. So make sure you configure an output directory. I then configure some standard resolvers. I found if I put too many in here, I tended to get errors. So I kind of just pared it down to a smaller subset of DNS resolvers to use for this test. And this is really used to resolve those names during your test. I think you want to give it like at least 4 here. Again, if I expanded out this list to all of them, some of them I got errors on and stuff like that. And then you configure the scope. So you can pin it to specific IP ranges. So if you're doing like an external pen test, you might want to include the scoped range for that pen test that you're authorized to do in the scope. In this case, I didn't do that because I'm like, whatever, I'm not doing anything like heinous to these IP addresses. And I do just configure some basic ports there for it to find this infrastructure on. So these ports are open. It will use those to determine if that host is in fact alive or not. Then I gave it to the domains. This is one I had some like weird command line kung fu to get like a bunch of domains on the command line. I find it easier to just list them out in the configuration file. This wasn't the full list that I was testing with. I probably had close to 20 domains that I was testing when I was doing the evaluation of attack surface monitoring tools. So this is just kind of a subset. But I so for each engagement, I would recommend, if you're doing this as a pen tester, or if you're doing this internally, just maintain a list of all your domains, stuff them in the configuration file. I found that to be the best and easiest way because, the more domains, the better, right? this does represent your attack surface, and that root level domain is really going to be the starting point for tools like AMASS and other tools that you would use in your attack surface monitoring. It does keep a graph database locally, so all of your results will be sent, if you configure it like I did here, to have a local database. The advantage with the local database, and I'll show you a really quick example, is you can do tracking. So you can run AMASS with one run, it'll save those results to a graph database. You go run it the next day, and you can run an AMASS command that will give you kind of a diff between those scans. So you can see if a domain doesn't resolve anymore, if that domain's IP addresses have changed since the last scan. So it'll give you the tracking results if you store it to a graph database. You can also send it to a Postgres database, and there's some different options there. But I find just setting local database to true did the trick for me. I did enable brute forcing. Otherwise, your results are kind of limited to just relying on the third-party kind of integrations from things like Shodan and the SSL TLS certificates. Enabling brute forcing gives you a lot better results. So I enabled that. I had it do recursive lookups as well. And I gave it just a basic wordless file. 5,000 domains was pretty much the sweet spot for me in terms of performance. Obviously, if you're doing a pen test or working on a bug bounty, you can have word lists that go much higher. And there's tons of word lists out there for DNS subdomain brute forcing, which is essentially what it'll be doing. And they can grow exponentially in size. So actually, 5,000 was actually low in a lot of the databases that I found for subdomain brute forcing. I did enable alterations, so it will try like different types of subdomains. So like if it finds www, it may try ww1 and things like that. So it does have some kind of like built-in automatic what they call alterations that will do that for some of the resolved names. And then you come down and you configure your sources. And this is where the config file is basically like required, is you're going to go out to a number of different sources. You're going to register for a free account. And these threat intelligence sources are going to be used when you scan to see if any of your IP addresses or domain names are in these particular sources. So it may take the IP address, cross-reference that with Alien Vault in this case, and vice versa. So I did, and Jeff totally recommends this as well. He's like, configure as many sources as you can, because these are just basically, most of them are free that he has in the configuration file. Some of them are paid, some of them are invite only. I configured just the free ones, and I probably increased my results by 25 or 30% just by going to all these websites. And it's kind of tedious, right? You got to go to all these websites, you got to register for an account. Then you have to verify your email address. And once you do that, you'll get your API key or your set of API keys. So I did Alien Vault, Binary Edge, Census, Cloudflare, Passive Total, Security Trails, Shodan, and URL Scan, and Virus Total, all in there. So I do, again, go to each one of these sites, register for an account, and this is where like storing all this in your config file is key, because all of your API keys and client secrets will be in there. Then if you want to test, like go on to your next pen test or bug bounty, you copy your configuration file, all your stuff is in there, and you just swap out your domain names and your config is preserved. Super easy. So then when it comes down to actually running AMASS, I did it like the wrong way. I'm missing a closing double quotes there, by the way. Because I was working with so many domains and there was a list of 20 of them, I used a little command line kung fu to just like basically take a file and dump the contents of that file as a parameter to the -d. That's not the way to do it. I like the config file better. So I told it to, let's see if I can remember what the command line options do. I meant to put that in the documentation. So -source or src will actually in your results file list out which of the sources found a particular DNS subdomain. So like if it came from Alien Vault, it'll list like, hey, I found this IP address in this subdomain, and that particular bit of information came from Alien Vault, for example. -IP puts the IP addresses inside of your results file as well. So you get a matching IP address and domain name in there. And then it lists the results. And like basically this could potentially be both IPv4 and IPv6 addresses that are resolving. And these are all of the subdomains that it's finding across all of these different sources that you provided, including some built-in ones as well. So you find basically a lot of stuff. I mean, like anyone can take a bunch of domains and run it through and find the associated IP addresses and subdomains within a top-level domain. Then there is the track feature, which is interesting. So in the track feature, I think because I couldn't get it to like read via the track from the configuration file, and I didn't want it to do all the things I had configured in the configuration file, I basically just said, hey, in the domains that I have, run the track against them and compare my last couple of runs. And what that does is it tells you like things have moved, like this particular domain name has moved from this IP address to this IP address. It looks like in that case, like the IPv6 maybe didn't resolve or was taken out. So it can give you kind of a nice tracking thing. I think this is more for your internal use case where you're constantly testing the same set of domains over and over and over again. And then I decided to like really quick, and this is really quick and dirty, but it's funny because Alex kind of teed this up in the previous segment in stringing multiple open source projects together. I ran AMASS as I configured it with the configuration file, and I output it to a results.txt. And then I use a little bit more command line kung fu. I go through those results and I pull out just the domain names from that represent all of my targets that maybe I didn't know about before because it found some subdomain running some service that's hosted, who knows where. So I collected just the host names from the AMASS results. Then from there, I ran Nmap against them, which is interesting because I couldn't figure out. I don't think AMASS actually stores like the port numbers. At least I couldn't figure it out from the documentation yet. If it actually tests those open ports and stores that in there. So I just ran a quick Nmap scan against them, which is key for some of the next steps. So I basically scanned 80.443 and 80.80 on all the subdomains that I found. I did a simple SYN scan against them, and I outputted my results to an XML format. Then, since I haven't done this in a while, I had to find a good tool for doing screenshotting. I actually worked on some of these tools, actually helping out with some of the code behind them back in the day. But Eyewitness was the one that I found. And props to the people that wrote Eyewitness. It's a great project, and it worked way better than all those tools I used to try and test and get running back in the day. I didn't have it installed, so like I included the installation rate in here. So I basically cloned it, did the Python setup, it installed, and when you run Eyewitness, you can pass it your Nmap XML results. You can tell it to hit the take screenshots --web and dump the results to a directory. It ran amazingly fast. I mean, there was probably 50 plus the host names in there. I mean, it ran super fast.
Don't you love that, right? Eyewitnesses, they've done such a great job.
Right?
Trance's crew.
Yeah. What's his name? I should have had his name in here.
Yeah, it's Chris Trance's tool.
Chris Trancer. Yes.
Yeah.
Yes, we know Chris. Chris, you did a great job. Fantastic tool. And they were advertising some kind of conference or something like after I ran it or built it or something. They had like this little like promotion in there. So definitely support the project because it ran really well. And you get HTML results with a screenshot of the website if it exists. It even takes a snapshot of the source code that existed on that front page, and you might be surprised as to what you find in your environment. I didn't put any kind of interesting results here. This is obviously our website that I found in the screenshot. But like all that, like putting together, I mean, discounting the time it took me to kind of read and understand how you build a configuration file for AMASS, that took me like less than an hour to basically install and run all those tools, string them together, write little tiny scripts to string them together, and ultimately come up with scanning all of your domains for subdomains and getting to a website where you can see a screenshot of everything that's on those sites. And what you'll find as a pen tester, as many of us know, is you'll find very interesting things that you're like, wait, why is that exposed? I didn't know I had that. Well, it was interesting. One of our sites was running some weird SQL. I don't remember what it was called. It was some light SQL kind of server. And when we looked at that, Adrian and I were like, we tested a whole bunch of tools for attack surface mapping and are starting to test tools in web app scanning and vulnerability scanning. And not many things actually found that so far. So like my cobbled together open source projects actually found something really fast that some of the attack surface mapping tools tended to miss. So I thought that was cool. Joff, Tyler, anyone else want to weigh in on your AMASS usage? Do you use it?
I haven't used it yet, but it looks extremely useful. I mean, the idea that it's just trolling different data sources and sort of taking your domains into account and giving you very, very useful recon data, that's amazing. It's fantastic. I love the idea, and I definitely see using it.
Definitely an invaluable tool from getting an engagement start, even before. We'll say before an engagement starts, as we're scoping out a potential client, or a client is ongoing. Like this is all public source stuff, right? So you're getting a sense from scoping, from general maturity, from platforms you're going to have to test. So even from pre-scoping, whether or not you want to do work here or what you're going to have to do from work, it works out really well, especially if you get a lot of the integrations. And building integrations isn't that difficult either, which is another really nice piece of this.
Yeah, I haven't looked into building a custom integration. If you have your own data source and you want to build a connector to it, have you done that before, Tyler? Is that not that difficult?
It's not too bad. It's not too bad. In fact, we're talking on Discord right now. One of the integrations that I haven't seen that someone brought up would be a great integration between like Bit Discovery, where you can use the Bit Discovery API and leverage that to integrate results for it. But yeah, you can definitely get integrations into a lot of different things. You can build different things with Slack bots and querying data sets against different aspects that you're looking at, or IP spaces, depending on what you're trying to query. But yeah, it's fantastic.
Yeah, a lot of the ASM vendors also have their own methods of aggregating stuff. So like you're aggregating the aggregators. So like any of that stuff you can pull in. Like if it were my company and I was charged protecting it, like this would just be running all the time, right? I mean, maybe I'd go out and buy a commercial one, but if you want to test the waters, like stringing this open source stuff together is a great way to get started. Also, it worked really well in my use case where maybe you just acquired a bunch of companies and you're like, well, I know what they tell me, right? But most of us could probably run it against our domains and go, oh yeah, I forgot about that. It was a great way for me to go to the IT team and be like, yeah, by the way, this is like everything I think we have. And almost 100% of the time they're like, yeah, I didn't know about that. And like, I thought that was shut down and I didn't know it was there. Right.
Yeah.
Mergers and acquisitions. This is one of the main use cases that we see for a lot of internal teams. If you're an internal team, obviously external teams, there's a ton of uses for it, but the mergers and acquisitions, getting that visibility and even just a start point for knowing what you have externally, because I mean, there's a ton of tools out there. You got like DNS Dumpster, you've got Grey Hat Warfare, you got like a million tools that you can use. But this provides a nice platform to go and hook in a lot of the bigger data sets and not have to go and do those individually, because external recon takes a ton of time. External assessments take a ton of time and resources.
Yeah, and I also love the fact that it's got universal appeal, right? I mean, the red team side, fantastic, but also on the blue team defender side, like it's just one of those things that is like you just should do it.
Yeah.
And that's that's always the mark of a good tool when it spans the breadth of the industry. So that's really cool.
And it's free and open source, right? Which is just amazing. And the performance, because it's written in Go, is great. And it also tees up the next couple of technical segments, because we can talk about vulnerability management all we want, but if you don't know what you have, your vulnerability scan results are always going to be crap because they're going to be missing stuff. So like, to me, this was the first step to go have automated tools that can go dig and find all those dusty corners, find as many assets as you can. Now the next step is to take this and run it through your vulnerability scanners or your web application scanners, right? Because most of the stuff you're finding is web app related, I've found. So I actually,
especially for free, right?
For free, right? I mean, all you need is some compute time somewhere. I mean, this could be I wasn't running this from the cloud. I ran this locally, right? You just need an internet connection, and it runs. It doesn't suck up too much bandwidth or even CPU. So then the next phase is, and I did a technical segment on this last year, I want to say, Cloudflare has a open source project called FlanScan. FlanScan is a container wrapper for Nmap with the vulner script. So I actually took the results that I had from running AMASS against all of my domains, and I funneled that through FlanScan. So I basically took the domain names, ran those through FlanScan, and I'm like, I can just totally script this together and stitch that together as well. And then you'd get full vulnerability scanning. I mean, not full, but you get a pretty good sense. Like, vulners is actually pretty good, especially if you're limiting the scope to external. You're not having as many exposed services as you would potentially internally. And I was actually pretty impressed with the results and the speed at which that happened. And that's just FlanScan. Now I've got like one-liner container command that just runs it. It's awesome.
It'd be really useful. Like, one of the problems I think I see commonly, like, there's this, right? You've got your IP space, you've got your domain names. That's going to do a pretty great job, and as a good starting point. One of the things I haven't seen, and if someone wants to figure out a way to do this, is figuring out a way to query all of the services out there for corporate domain email registration, right? Like, you've got all these IT groups, DevOps groups, people registering underneath of corporate emails that may have corporate information stored, but if they don't inform you of this, how do you actually know what you have out there? That's one that's, I think, going to become a bigger issue as we move more to the SaaS and the cloud. I think we're going to see more of a demand where there's going to be a way to enumerate what assets your email address is correlated for accounting.
I think Hunter.io does that, Tyler, but I think you got to pay for that.
You do pay for part of it.
Right?
Yeah, and it depends on if the site can do username enumeration, whether or not they've got it in breach data. There's a bunch of different ways that they do that correlation.
A lot of the ASM tools will include that as well, but most of those are commercial. Some of them do have free offerings as well.
It feels like, Tyler, you're looking after cloud-based shadow IT now to really...
Well, I mean, as you move to SaaS, right? Like, that is one of the things, like, we scour the web looking for, who's mentioning something on, the latest, one of the latest forums. Hey, how do we do this on this particular SaaS platform? And so we go look at that SaaS platform and try and get into that data, because, most of the time IT does not know all the places that either, even accounting groups go out and use software underneath of the corporate account that IT may or may not know about.
You could parse some of that data from AMASS, because I had it do the reverse lookup on the IPs. That reverse lookup usually, like, it'll return an Amazon pointer record, basically, with the domain. And all you need is that URL, and that's your starting point to start digging into their cloud infrastructure. And even just having that list to go back to the IT team and go, here's what I found of, like, in this, I looked at all of our domains and then what IP addresses, and then I did a reverse of all those IPs. And now I have this list of, here's our Amazon infrastructure. Like, do you folks know about all this stuff? I bet you there's like, wait a minute, someone spun up something new because I don't recognize that.
Yeah, and who's managing the IAM for all of those? Are all underneath the same account? Do you got root
Yep.
Like that's where the cloud and the SaaS stuff really starts to get complicated. And it's a huge footprint and risk vector from, like, you used to be able to have it all underneath of a single IP, or at least sit behind your firewall, right? So you could figure out and enumerate it with some scans. But now with all the SaaS providers, you really don't have a full grasp on that. And even if you think you do, you don't.
Yep.
So is it fair to say that if you didn't sort of practice, proper IT hygiene in terms of inventory tracking, then you're probably screwed now?
Do you more so? I mean, that's spot on, Jeff. That's that is the state of affairs today.
It's totally something that you can monitor.
But it's okay,
right?
Because the cloud provider is PCI compliant, right?
They provide you something. They provide you cloud.
I love the aspect of sort of continuous monitoring of your DNS surface as well, right? Yeah. That's like you're out there just polling, and like Paul was saying earlier, he got a sense of what's out there pretty quickly that you've probably forgotten about, and that could apply to any one of the domains, plural, that I own. It's a great thing.
Yeah, and the commercial tools, I wish I had a quick and easy URL off the top of my head, but Adrian and I, we run SC Labs, or SW Labs as we now call it, and we're testing these products in all these different categories, and we completed a group test of, like over a dozen different attack surface monitoring tools. AMASS was one of them. So we're incorporating open source tools. So like the next one we're working on is vulnerability management. So I'm looking at OpenVAS and I'm looking at Nmap and Vulners in the open source realm. But the commercial tools in attack surface monitoring do some amazing things, right? Like they all have like these slightly different features and they're all kind of amazing in their own right. And it was interesting to see the results from almost a dozen different tools I think we tested live, and see like, well, this one found this and this one found this other thing that was different. And I'm not saying everyone needs to go buy a dozen tools, but like find one that works for you in your budget and meets your requirements and operationalize that stuff, because reducing your attack surface is awesome. And also knowing about what you have out there at least gives you the opportunity to address it. And that's why I say operationalize it, right? Like take these results and try to funnel them into your processes, because it's going to speak volumes. I mean, we read in the news every day, OpenS3 bucket here, someone got hacked here, and a lot of that's just because you got a website hanging out. Don't, if you're going to have a bug bounty program, great, but like do this first before you have a bug bounty program, because this is the first thing bug bounty hunters are going to go to. So it's good stuff.
And the SW Labs, by the way, Paul, is securityweekly.com/reviews if anybody wants to go to it.
I feel like I should have known that, right?
Yeah. You should have known that. Yeah.
There's so many URLs.
So you're young. You can keep track of them.
If only you had a way of inventorying it.
Right? If only I paid attention to all the results.
Oh my God. We've come full circle.
I got an old fart question. That was we used to worry a lot about scanning everything we have both from the inside and the outside, but this sounds like you're not so worried about that. We're vulnerable.
I don't think there really isn't an inside and an outside anymore, Lee, right? Like with
that's
SaaS,
why I said it's an old part question.
Yeah,
it's all out.
It's a hard problem though too, because you do still have there's still that distinguishing physical hardware that you account for, but when you're talking about inside and outside, if you label those as from the security side, then there's some misnomers that end up happening. But if you don't label those, then really understanding how to secure them and how to inventory them and keep track of them becomes another problem. And then you just end up with being stuck and not doing anything. So really, this is a problem that we've been mulling over for, I would say, years, but it's come up to the surface over the last year very, very heavily, especially with work from home and trying to come up with innovative solutions and even just recommendations for organizations that are having to deal with this right now. That's very difficult. And I think this is a problem that everybody's facing. So I think there's some solutions out there, but I haven't seen anything that's phenomenal at doing this from start to finish.
The evolution for me, Lee, is I wouldn't spend a lot of time trying to run a vulnerability scanner in the traditional sense. against my external facing infrastructure. And I think it was a tactic years ago that might have worked. But the thing with a vuln scanner is you have to give it a list of targets. Like a traditional vuln scanner doesn't go out of its way to find new targets. Like, it scans what you give it. That's why I like attack surface monitoring, because it's going to great lengths, pulling from all these different sources to find as much of the stuff that belongs to you. And to me, in and of itself, it's a finding. A lot of the ASM vendors today, Intrigue, Risk IQ, I mean, there's a whole list on the reviews. We went through all of them. They'll actually find some vulnerabilities in there as well. And it's enough to, like, it doesn't have to go very deep. Like, if I've got WordPress out there, like, I want to know about it, because if I didn't know about it, chances are it's probably vulnerable. I need to pay attention to it. Do I need to do a full vulnerability scan of every single TCP and UDP port on it? No, I just need to know that it exists. I think internally for me, I want something that has an agent. It can give me those rich results from all of the different things that I know about. And maybe you do some discovery internally. But for me, vulnerability management on the inside is all about having an agent on my assets.
Yeah, it's funny you should say that, Paul, because I'm sorry, Lee. I'll let you in a minute. I've been doing some research on my own the last month or two in anticipation of version 4 coming out of PCI and what is coming new in terms of the requirements, which I'm not allowed to say what's new. But I can say it has something to do with the whole notion of internal versus external, scanning and pen testing for that matter. And I've even had this come up recently with a client that's doing basically their whole operation in the cloud. Doesn't matter which one. Pick one of the big three. And PCI requires an internal pen test, internal vulnerability scan, as well as external. External people pretty much get internet-facing, publicly routable addresses, but they were kind of scratching their heads, and we were kind of scratching their heads at, what's it mean to do internal when not so much that it's in the cloud, but so much of it is ethereal. Is that a good way to describe it? I ask our, my compadres here, is it helpful at all to think trusted versus untrusted in this context?
I would say kind of, right? Like, you have certain internal assets that are probably more vigorously deployed based on an SOP or some configuration management, and thus you control some of that with things like Active Directory and
you mean the stuff you know about because you use it, but not the stuff that Paul's talking about.
But even if you know about like your SaaS applications like Slack, right? Like, you may not have particular logging or visibility or even the capability to do vulnerability management against that platform, right? That's not authorized or is not done. So whether or not you control it, I think it's less about trusted. Well, I think it is kind of trusted versus maybe untested. You're relying on someone else.
But I can configure Slack to be really insecure, right? Isn't there a way to configure Slack where anyone can join and send messages and stuff like that?
Oh, yeah. Yeah, I mean, not only that, but the APIs that are exposed and how the channels are configured, whether they're private when they're set up. Like, you can do a lot of interesting things with things like Slack that companies just don't know about. So, again, the configuration control and management of those, again, we're back to the problem. This is someone else's infrastructure and application that it's still a trusted application from the standpoint of internally. From a security standpoint, yeah, you shouldn't trust any of it. So I don't know. Maybe you're right, Jeff.
I don't know if it's like a binary decision as trust and untrust. I think you should, of the applications you know about, start there and understand the roles that different users should have. Like, should it be, it's kind of like a matrix, if you will. Should it be exposed to the internet? You're like, yes or no. Okay, if it is exposed to the internet, should it be authenticated for everyone? And then if it is authenticated, what should some of those roles be? And then be able to test that. Like, Slack is a great example. Okay, do we have Slack? Yes. Okay, we're going to prove that as an application. Should just anyone be able to join our Slack server, or should there be controls around? And what are those controls? And then test to that.
Mm-hmm. Well, yeah. So that's an interesting phrase you're using, Paul. So not internet reachable, not routable to the internet. The internet shouldn't see it. Is that not a way to define what we used to just call intuitively the internal or corporate network?
So I think the operating question, though, is the internal or corporate network, are we finally at the point where it's basically gone? You know, I mean, it's, I think that's what we're
gone right? In the context of it's not in the basement, it's not down the hall, it's right. Not in the, you know, the distant building on the campus, which is where they always put IT in the first place. You know, so it's not it's not physically present anymore. But you know, but if that's the way you're thinking of internal in 2021, maybe we need to up our game a little bit just in terms of clarifying the terminology that we use.
Well, I wouldn't just say internal, right? It shouldn't be trusted any more than a cloud or AWS or Azure AD. Like any of those things, I don't think are more or less secure than the internal. In fact, I would probably argue that your internal network is probably less secure and has more holes popped in it in order to enable the SaaS applications or to enable remote workforce or whatever is happening. Those distinguishing lines are still there. They just don't mean anything anymore.
Yeah. So
let me put it this way.
What comes down to, though,
go ahead.
Sorry, Jeff, is that for a long time, I think for years in the industry, we sort of defined these network parameters in terms of communication boundaries, but that's no longer the case. I mean, communication boundaries are actually irrelevant. The network today is treated as a transport, and so the actual security boundaries lie with user authorization today. And the control plane into these various technologies that are distributed everywhere. And so, you know, the issues that we've all struggled with, the issues of password strength, the issues of 2FA, the issues of actually securing those attack surfaces that are more broadly distributed, is really where the issues are. Network is kind of irrelevant today.
Yeah, I was sort of going along the same lines, Jeff. What you're describing, you know, comes from, I think, the way that we approached network or internet security in the early days, and it's based on sort of traditional defenses, which are physical. So, you know, think of the castle with the moat, think of a fortress and layers of protection. I mean, all the stuff that we built into the early days of the internet was based on, you've got all your stuff physically in your building, and you have your own network, and now you're plugging into the internet, and that's the vast unknown, untrusted area. And so everything had to do with the perimeter protection. But my question I wanted to ask, since we're you're sort of leaning in the direction where I think it's appropriate that we're going, Jeff. But where today do you as an organization keep your most critical assets, your most critical data assets? Where's to use the old-fashioned terminology, where's the mainframe? Where's the database that's got all the crown jewel? Where do you put it, and how do you protect it?
In the cloud.
So I think what dovetails immediately into that question is any regional compliance and regulation issues, because that has and will continue to be an issue for all the cloud providers, that data has to have certain geolocality, and so we have to handle that. But ultimately, what Paul just said, sort of flippantly, is in the cloud is the answer. Right, they're really consolidated data centers is what the cloud really represents. Okay, great, and the same issues in security apply now that they've applied all along. Right, is the CIA triad, right, which is that confidentiality, integrity, and availability. The world of encryption technology is still extremely relevant, extremely important. Because now it's distributed across the entire internet. And the world of VPN technology, although related, is becoming increasingly irrelevant, because the VPN world was really based on the idea that you're getting inside the moat where the castle is. And, the moat now is in all kinds of places. So I think we have distributed VPNs, but we don't have like sort of one central VPN anymore.
Yeah, I don't think it matters where the data lives. It's more how you protect it, how you protect the applications that allow access to it, how you protect the users and their identities that are access to it, and how you manage that access.
Exactly,
right?
Paul. And the focus has to be on the data, not on the heavy hardware that's in the basement.
Yeah. Right.
And it's interesting what you said, Joff, because you said all the security rules haven't changed, but the way most of those security rules are written down, PCI being a good example or a bad example, they're written in the context of the old way that we used to think about the network and the way things are structured. And the challenge right now is to take the security requirements that haven't fundamentally changed, but to be able to restate them in a contextual way that makes sense for the new technology and the new environments that we're living in.
Yeah,
and
so
I think, Paul, you're right. It's got to be data centric.
And I think in my example, like to me, when I run these attack surface monitoring tools, it doesn't matter to me where the application lives in any cloud provider or whether it's on premises. It doesn't matter if it's reachable from the internet. It gets classified in this bucket of I can reach that from the internet. If the back end, if some of it's on premises, some of it's in the cloud, like it doesn't matter. It's reachable, and that's really the finding, in my opinion.
So in specifically in the PCI context,
hold on, Lee, then Joff.
Yeah, sorry.
Okay, so I agree with you, but there's two nuances that people have to start getting their head around. Is that unlike the old castle model, it's not just your machine anymore. It might be shared with a whole bunch of customers. So now whatever you do, whether you're scanning it or whatever, you have collateral damage potentially as you've got others in the loop. And the other is you have to really understand how your data is protected. I mean, Jeff mentioned encryption, but it's also separations and who can control those separations. I mean, I've run in systems where the separation is simply a customer identifier in a column. And when you log in the app, you're limited to that column, but somebody with admin at the back end can see everything, which isn't necessarily okay. It's a change we're not yet fully grokking. We're getting there.
I feel like mainframe. I feel like mainframe people really got that.
They really did get that.
Right? They really did. But, and because it's very similar to cloud in that you've got all your applications and data in one massive mainframe that was running all of it. It's very similar to going to a cloud provider, and I've got all my data there, and I've got all these services that are allowing access to that data and applications using those services, and I've got to control the roles. It's very similar. But at the end of the day, it doesn't matter whether it's on one big mainframe, Jeff, right, that's sitting in my corporate headquarters, or it's a set of cloud native applications, and everything is in the cloud, or some combination of the two. I still have to maintain security controls around apps, users, and data.
Yeah.
But so I would add,
to make one comment on PCI, if I would, just in that context, really quick. I think just the comment that occurred to me is both the strength and the weakness of PCI was that it was a little bit too over prescriptive tactically, and so I think what PCI is struggling with right now to reinvent itself is how to be a little bit more generalized but still be tactically useful.
I don't know. That's a double-edged sword, Joff, because I kind of like that PCI was more specific than a lot of other compliance standards.
It is a double-edged sword, right? I said it. Strength and a weakness.
It's a strength and a weakness, and I agree and I disagree, Joff, because I don't think that PCI is terribly prescriptive. It's actually what most people think of when that is said, and people say that a lot, it has to do with how often do you have to scan, how often do you have to do a pen test, and everything to do with password strength and expiration and stuff like that. Oh, it's horribly prescriptive. That's about the only detailed thing that's in it. Everything else is build your systems, harden your systems using an industry accepted standard. And it doesn't say which standard to use. It doesn't say which elements of the standard apply to you. It just says use something that's industry recognized. And I come in as a QSA and say, what are you using? and are you using it? So to me, that's not prescriptive. To me, that's wide open. You do whatever you want, have whatever running on your system you want. Just know it's authorized, and if it's insecure, have protections around it. Don't use the insecure stuff.
Yeah, I mean, 11.3 says have a pen test. Doesn't say have a good pen test.
Yeah, but
it doesn't even really say what the pen test should be.
Right.
I'm sorry, Jeff. Go ahead.
Is it not true that PCI in its current standard still does make reference kind of to the moat model that we just spoke of, and that's a little too prescriptive?
It was written originally with sort of our traditional moat model, but it was also written from an e-commerce 3-tier architecture perspective. So you have internet-facing systems that the world communicates with, that talks to a middle layer DMZ that controls the communication in and out of your network, and then you have all your applications and databases and all the crown jewels are on the deep and the eternal. So in that sense, yes, it's very much written in that context. But guess what? I can't say what percentage. I'd say easily a simple majority, if not the vast majority of companies, especially the smaller companies that have to do PCI, but they don't really have the budget for IT, yet alone security, they're running to the cloud, and more they're going to the cloud. Sure. And we're having to figure out, how do you make these security requirements that were written in an older context, how do you translate them to you have to do this still. It still applies, but what does it look like when you're doing something in containers, when you're doing something in a virtualized environment? And what's the most tricky part about it is, real quickly, you've got a merchant. They want an e-commerce site, and so they enlist a third party to write the application, maintain the application, and that company does all its development work in the cloud, and they do the hosting of the app in the cloud. But when it comes time to checkout, you've engaged a third party, like a Stripe, or I shouldn't endorse anybody. It's not an endorsement, but a right. payment processor that does the checkout, and that's yet another party. And so you got 3 or 4 companies that are all in this mix, and it's all hosted on a cloud provider, and all the requirements apply, but who's responsible for what? That's tricky.
Yeah. Well, I think that you made actually a very good point in that discussion, and that is we need to refocus on the data itself and not so much on the infrastructure pieces parts, right? Protecting the data is what's most important, and I'm pretty sure in your efforts for the next standard, it's going to be much more focused on the data, which is the right approach, I think.
Absolutely.
Well, and what I was going to say when Paul brought that up originally is, and by the way, the data isn't in just a database and people like checking in and check it out. It's everywhere. It's on, it's on the personal devices. It's on the tablets. It's working from home. There's something on somebody's workstation or laptop or whatever they're using. But even before the world shut down, data was everywhere. I mean, Paul and I have talked about that in the past.
That's the problem, though, right? Is the cloud doesn't solve any problems. It actually adds to the complexity. Now you have someone else's software on the same infrastructure you would have internally that you control that you now don't control, and you just have limited control over the configuration, and that configuration is where everybody messes up. So whether their hardware or underlying OS or virtualization is all PCI compliant, whatever compliant SOCs to, all of that's in order, you still have configuration to worry about, and people are still messing that up. And that's where the big issue is nothing is getting solved moving to the cloud, and everything is still a mess. It's just a
different mess,
disenfranchised mess all over the place.
Just like AWS configuration leads to 5 million records and so many more stories that we're going to cover next, including new executive orders, and there's a pipeline that was hacked. So stay tuned.
We weren't even doing the news, were we?
Stay tuned. Nope. Security news coming up next.